So in part B, we are told that now two students ask the teacher to be placed in different groups. So one of them wants to be in group 1, the other in group 2. And the teacher finds now that the total number of ways they can make the group has halved. And we need to find the value of n. So we can have two cases here. We can either have student 1 in group A and student 2 in group B, or we can have student 2 in group A and student 1 in group B. So let's look at the first case where student 1 is in group A, group 1, and student 2 is in group 2. So the number of ways we can do that is, well, we need to take the first student in the first group, so that simply has a combination of 1. And then for the rest of the students in group 1, we need to choose 2 students, but we cannot choose B, and we have already chosen A. So that's 2 less than the total number of students still available. I mean, in total available. And then we need to place B in the second group. Again, that doesn't really have a chance. We could use the same reasoning as in part A. So the rest simply has a combination of 1, as we don't really care what combination they're put in. We just need to put in all of them. So that just has a combination of 1. So this is simply n minus 2 choose 2. And if we think about it, if student 2 is in group 1 and student 1 is in group 2, then nothing really changes. It's still the exact same situation. There are no other conditions that we have to fulfill, so that's going to be exactly identical. And then we are told now that the number of ways the teacher can assign the group has halved. So what that means is that this initial thing we have found is twice as big as what we have found now. So what we can say now is that n choose 3 is 2 times the combinations for this. So this was 2 times n minus 2 choose 2. As for both cases, we had this many choices available. Doesn't matter which one we did. So let's write this out factorially. So this will be n factorial divided by n minus 3 factorial 3 factorial. And then this is 4 times n minus 2 factorial over 2 factorial minus n minus 4 factorial. So we need to do some simplification here. So if we think about, I mean, we could do this very quickly, but we could also write out what is happening here so that we understand. So, well, 3 factorial is 6. Here we have a 2, 4 over 2 factorial. So overall, we'll just have n factorial over n minus 3 factorial times 3 factorial is equal to 12 times n minus 2 factorial over n minus 4 factorial. And now we need to simplify the factorials. That 3 factorial should not be there. So here this n factorial is like n times n minus 1 times n minus 2 times n minus 3 factorial. So we could just replace this with n times n minus 1 times n minus 2, as we have an n minus 3 factorial on the bottom as well. And it's kind of the same thing over here. So n minus 2 factorial is the same as n minus 2 times n minus 3 times n minus 4 factorial, but that cancels out with this. So very nicely, we can cancel out these n minus 2's. So we're just left with n squared minus n is equal to 12n minus 36. So we can bring everything to the same side. And then we can factor this quadratic. We get n minus 9 and n minus 4. So the two options we have is n is equal to 9 and n is equal to 4. But here we have to look back to the start of the question where they say both groups need to have at least 3 students. So only having 4 students in total is not possible, because then the first one would have 3, the second one would have 1, and the second one needs to have at least 3 students. So n equals equal to 9 is the solution to this question.